Android is the most widely used operating system in the world. Hundreds of OEMs ship devices on top of it, customizing the OS every single year. Google releases a new Android version, but on day one it's only available on Google's own Pixel devices. Third-party vendors like Samsung typically deliver the new version to their flagship devices within about 3 months. But 10 years ago, that delay was anywhere between 9 and 12 months. And non-flagship devices often never receive the update at all. So the obvious question is, when will Google be able to do what Apple does? Ship a new OS version to all devices on release day. You're watching Android Broadcast. I'm Kirill, and here we talk about everything related to Android and Android app development. In this video, I'll walk you through how Google has been reshaping Android's architecture for years to shorten update timelines, reduce OEM dependency, and eventually eliminate the need for major OS releases altogether. When Android launched, Google's strategy was to act purely as an OS developer, licensing the platform to hardware manufacturers instead of shipping its own devices. Once an OEM receives the base build of a new Android release from Google, they customize it, replace pre-installed apps, change the visual design, add proprietary features, and often modify core Android mechanisms. That impacts third-party apps and makes life harder for developers. This approach led to device fragmentation. The market became flooded with devices that differ in hardware specs, OS versions, vendor customizations, and pre-installed software. There are several reasons for that. Google develops the operating system, but OEMs are responsible for shipping updates to their devices. Adapting a new Android version used to take vendors anywhere from 6 to 18 months. Sometimes the next Android version was already out while an OEM was still adapting the previous one. And those numbers applied to flagships a decade ago. Budget devices were in even worse shape, often receiving no updates at all. The second reason was Android's monolithic architecture. For OEMs, the update process was a nightmare. First, they had to wait for a stable release from Google. Then they needed to merge the new AOSP code with their existing customizations. After that came compliance work for new Android requirements and integration of new platform features into their proprietary UI layer. Then testing, then rollout. The third reason was economic. Smartphone manufacturers primarily make money from hardware sales and preloads. Services, subscriptions, and in-app purchases, that's where Google earns. So, OEMs are incentivized to push new device sales, sometimes by delaying updates for older models to give newer, more expensive devices a competitive edge. Google wasn't happy with this situation. Around 10 years ago, the company launched a long-term initiative to accelerate Android updates, regain control over feature delivery, and enable direct distribution of platform updates to users, bypassing OEMs. That initiative is called Project Mainline. The idea came from Google's core Android team. The goal was to modularize the OS, to isolate Android platform code from vendor implementations. That started with Project Treble in Android 8, which simplified adaptation of new Android releases. With Treble, OEMs and silicon vendors only needed to update their side of the interface without modifying the Android framework itself. However, full adoption took years. Treble became mandatory only for devices that launched with Android 8 or higher and included Google Play services. Update speeds improved, but Google still couldn't update the OS independently of OEMs. Android was no longer a single massive monolith, but it was still large enough that every platform update required OEM integration and a full firmware rollout. A new architectural shift was needed. That's where Project Mainline comes in. Mainline breaks core system components into independently updatable modules. These modules can be updated separately from the full device firmware and delivered directly from the OS developer to the end user. Project Mainline debuted in Android 10 with an initial set of 9 updatable modules. At the time of recording, Android 16 is current, and the system now includes over 50 known modules. If you're curious which mainline modules exist on your device, you can check using the Mainline Modules app from Google Play. I'll leave a link in the description. Modules can be distributed in 2 formats: standard APKs or APEX modules. APK-based modules are installed while the device is running, just like regular app updates delivered through Google Play. APEX stands for Android Pony Express. It's a special container format designed for low-level Android system components that require a device reboot to apply. For example, updates to the ART virtual machine are delivered as APEX modules, because you can't update that component at runtime. Eventually, you'll reboot your device and the new modules will be applied. The system may also prompt you to restart. Google also implemented an automatic reboot mechanism, complemented by direct boot, which allows limited app functionality before the user unlocks the device. That way, you won't miss your morning alarm. APEX packages have a structure similar to APKs and are signed in a similar way. Because they include an Android manifest.xml, you can use the same tooling, including ADB. Module updates can technically be triggered by any app with sufficient privileges. OEMs could implement their own solution. But on devices with Google Play services, module download and updates are handled through GMS. While alternative ecosystems could theoretically implement something similar, in practice only GMS manages mainline modules. Everything else is still delivered via firmware updates. This approach allows Google to backport new features from recent Android releases to older OS versions, without OEM modifications and without requiring additional libraries from developers. But how do developers actually use these new features? Module updates can deliver functionality to older Android versions. But if that functionality exposes new APIs, developers need a way to access them through the Android SDK. That's handled by a special mainline module, SDK Extensions. The primary use case of SDK Extensions is backporting APIs from newer Android releases to earlier platform versions. Extensions are versioned by Android release. For example, R extensions, U extensions, and so on. To use extension APIs, you need to specify not only compile SDK in your build.gradle, but also compile SDK extension. Once configured, the new APIs become available. Previously, you would gate functionality using SDK version checks. With SDK extensions, you need to check the extension version corresponding to the Android release you're targeting. For example, Photo Picker was introduced in Android 13. Thanks to Mainline, it became available on Android 11 and 12 devices as well. To determine whether you can use it, you must verify that the required extension is installed. You do that using the SDK Extensions API. Call getExtensionVersion, passing the API level corresponding to the Android version. The method returns the installed extension version, which must be equal to or higher than the version specified in the documentation. To find out which SDK extension version introduced a specific API, refer to the official documentation. Android Lint will also warn you if an extension availability check is required. For testing, you can create an emulator image that supports extensions or test on a real device with Google Play services. Project Mainline significantly simplified Android update delivery and feature rollout. It also made it possible for Android to move to a more frequent release schedule. Now Google can ship a platform update with new modules included, and later update those modules over the air. That's exactly what happened with Android 16. The updated platform is released in early summer, and additional module updates deliver new capabilities later. Some changes are still bundled with OEM firmware updates. If you enjoyed this kind of deep dive, leave a like. Let me know in the comments what you'd like to explore next. On this channel, you'll find more content like this and detailed technical breakdowns. Have a great Android. See you next time.